At its core, data is a collection of facts, observations, or measurements translated into a form that computers can process. But not all data is created equal. We typically categorize it into two main buckets: structured and unstructured. Structured data is highly organized and follows a strict schema, like the rows and columns you see in a financial ledger or a digital spreadsheet. Think of it as information that fits perfectly into a predefined box. On the other hand, unstructured data is everything else. This includes emails, social media posts, and videos, which do not have a rigid, predictable format. While structured data is much easier for machines to search and analyze, unstructured data actually makes up the vast majority of the digital world today. Understanding this distinction is the first step in managing any modern technical system. Once we have data, we need a place to put it and a reliable way to move it. While a spreadsheet is excellent for individual analysis and small-scale calculations, it lacks the relational power of a database. A database is specifically designed to handle massive amounts of information while maintaining complex relationships between different data points. However, data is rarely useful if it stays locked in one place. This is where the Application Programming Interface, or API, comes in. Think of an API as a digital messenger that allows two different systems to talk to each other and share data securely. By using APIs, we can pull live weather information into a mobile app or sync customer records across different platforms instantly without manual entry. Data comes in many flavors, from simple integers and text strings to complex binary files like high-resolution images and audio recordings. Each type requires specific processing power and storage logic to be useful. But regardless of the type, the most critical factor is data quality. In the world of computing, we use the phrase garbage in, garbage out. This principle means that the output of any system, no matter how advanced the algorithm, is only as good as the input it receives. If your source data is biased, incomplete, or formatted incorrectly, your results will be fundamentally flawed. Ensuring data integrity through constant validation and cleaning is often more important than the actual analysis itself. Finally, let's look at how data actually flows through a system. It usually begins at the ingestion stage, where raw data is collected from sensors, user inputs, or external APIs. From there, it moves into a processing phase. This is where the garbage is filtered out and the data is transformed into a usable, standardized format. Once processed, the data is stored in a warehouse or database, where it sits ready to be queried. The final stage is delivery, where that data is presented to a user as a report, a visualization, or even an automated action. Seeing data as a moving stream rather than a static pile helps us build more resilient and efficient digital architectures.